Okay guys, so for this one, we're going to be finding the vapor pressure of ethanol in millimeters of mercury at 34.9 degrees Celsius. That's important to note right there. That's our T2. Our delta H is actually going to be that. This is going to be our P1. And then also this is going to be our T1 as well. Okay, so those are the important notes to know about this problem. The reason why we want to know that is because we're going to be using this formula. It's ln of P2 divided by P1 equals the delta H divided by the constant times the 1 over T1 minus 1 over T2. Okay, so now that we have that going, let's go ahead and start plugging in. Okay, so we're going to have our ln of 2, I'm sorry, our ln, and then we said our P2 was going to still be the same. So we're going to keep that, P2 divided by our P1, which was 400. Okay, and that's going to stay there. This is going to equal our delta H, which is the 39.3 kilojoules mole, and then we're going to divide it by our constant, which as we all know is 8.314. Okay, and then we're going to go ahead and multiply all this by our 1 over, and then our T1, which is going to be the 63.5 plus 273, just so we could actually get it to kelvins. Okay, so I'm going to make sure we have that. Oops, sorry. Minus 1 over T2, which is 34.9, plus, of course, 273. Okay, now that we're going to have all that, we're going to just go ahead and solve. And then it's going to actually look like this. So ln of P2 over 400 is going to equal, after calculating all this, we arrive at 1.3, negative 1.3. And then now, to actually get it to where we're having our P2 by itself, we're going to go ahead and multiply, or actually, yeah, multiply both sides by E. So what's going to happen here is we're going to raise this to the E, so this is going to cancel, and we're going to raise this to the E, so we're going to have negative 1.30 as that. These cancel, so it's P2 divided by 400 equals that. So now we're going to go to multiply by 400, and these cancel, and multiply by 400. Okay, so P2 is equal to the E raised to the negative 1.30 times 400. Don't forget your units like I am. Okay, and once we have all that, it's actually going to come out that our P2 is equal to 109.0127, and it goes on for a while, and that's going to be in, of course, millimeters of mercury, and that is our answer.